Hey guys, my name is Austin, and in this course I'm going to be teaching you intermediate C# principles that will apply to create a simple text-based RPG in Unity. We're going to go through creating a cool little RPG that will have multiple rooms in a floor of a dungeon, and each room will consist of a chest or an enemy or the route to the next floor, which will have the same things: more rooms, more chests, more enemies. You can loot the chest, maybe you'll find a trap or an enemy or some gold and items. You can kill the enemies, and they can also kill you. And they can, when they die, you can loot their bodies for items and gold. The whole point of this is to teach you a few C# intermediate concepts, including inheritance with polymorphism and ways that we're going to be able to override virtual methods. We're going to talk about properties. We're going to talk about a couple different things like coroutines, some events and delegates. It'll be pretty cool to do, and we're going to learn a lot of stuff that hopefully you can apply to your own games in the future. Now, we're only scratching the surface of the medium difficulty, the intermediate C# stuff, but these are definitely things that you'll be using a lot in the future. So I'm going to go up here and click New and create a new project. I want to call it Text RPG. It's going to be 2D, doesn't really matter for this, and I'm going to click Create Project. So in the first lesson, we're going to be creating the character base class that we use to build our player and our enemy classes from. So if we think about what a base class is, we want to think about what we can construct other classes with. So if we're talking about characters, we're talking about the player and the enemies. We'll say we have a raccoon and we have an evil walrus. It doesn't really matter what you have. Then you have your player. What I want to do is I want to think about what properties, what information, what functionality that these things have in common. And I can think about this in forms of real life objects. So if you know object-oriented programming, which is an intermediate course, so I expect you to have a basic understanding of classes, objects in C# and working a bit with Unity. But I'm definitely going to explain everything in detail anyway. So if we think about objects, they're blueprints for creating something, right? You're going to define properties, and then you're going to use that information to build the object. So if we think about our enemy and our player, what they're going to have is they're going to have stats. We're going to say the enemy is going to have a health stat, it's going to have an attack stat, a defense stat, it's going to have a list of items, an inventory, if you will. It may have a position in the world, so we know what room it's in. It'll be able to take damage because it has health, and if it has health and can take damage, it can probably die, right? And that's going to be what our enemies do. And then if we think about the player, well, we can understand how they would also have to have health and attack and defense and a list of items, our inventory, the items that we currently have, some gold maybe. It'll have the ability to take damage and die because it has health. And it will also have a position in the world. So we can think about those two things for different objects, but they share that. They'll have more than that too, but that's definitely something they share, something they have in common. And what we want to do is we're going to create a base object that has those features that we can then use. We can extend those features with different objects. So we have a base class that has those stats and those take damage and die methods. Then on top of that, we'll build our player, which will use all that stuff too. It'll fill out the stats and we'll have those methods. But we'll also have a couple of things unique to player on top of that. And an enemy will have those things, well, stats, and take damage, and die, but they'll have a couple of things unique to them. But the base for both of them is the character class, something that defines what a character is. And this will make more sense as we go through and actually build the character class, and then later on add the enemy class that extends the functionality of our character class. And the same for the player. It extends the functionality of the character class. It, as we're going to call it, it inherits the functionality from the character class. So to do this, to show you an example of how this works, let's go into my assets folder. I want to right click, go to create. I want to create a folder for my scripts. All of my script files will live here. I'm going to go into that, right click, create a new C# script. Done all this before. Character, just like that. I'm going to open this up in Visual Studio 2017. So here we have the default template for a class whenever we create one in Unity. We have the class name and the script file name being character. And then we have the colon here. This is mono behavior. And just quickly, I'll explain what this is doing because we'll be using this for our own stuff here in a little bit. So we have character, which is the name of the class we just created. But then we also, on the right side of the colon, we have something that we're inheriting from, mono behavior. All components in Unity are mono behaviors in some form, right? They may be child objects of other objects that are inheriting directly from mono behavior, but that's kind of part of the inheritance chain, and we'll also get into that as we build up our objects. So we're actually inheriting from mono behavior with character. That's how we have access to different things in our character class. So if we think about how our start works and our update works, these things happen when these objects are initialized and used in the Unity scene as components. And the only way this works is because we're implementing and inheriting from mono behavior. Just thought I would show you that quickly because we're going to be using that for our own stuff here in a little bit. So what I want to do for this is I want to get rid of all this in here. And the first thing I want to talk about is we're going to talk about scoping our objects to different scopes. And if you know what that means, what it means is if I have an object that is defined within another object. So we have a class here. This class is an object called character, right? So inside of this, we would define a variable perhaps. We'll say we'll make a public variable that's an integer, and we'll call it health. So what this means is that now character has a health variable. We know how this works, done this a million times. Again, this is not a beginner introduction course, this is an intermediate course. So health belongs to character, and it's publicly accessible to other objects outside of character. But what does that mean exactly? That means if I have a direct reference to the character class in some form, in some way, that I can then, without restriction, access the health variable on that because it's publicly available to everything that has access to this object. It's very simple. That means I can read the information from it and I can write information to it. So I can get the value and I can set the value. So if I want to set the health to 20, I can do that. If I want to see what the health is, I can get the health and it would be 20. Pretty cool. But what if this was set to explicitly be private? What this means is this is only accessible within the scope that it is defined in. So if you think about the scope that it is defined in, all that means is the area that it was defined in, just the object that it was defined within. So this was defined within character, which means any functionality that I have in here, inside of character, can actually access health no problem. Okay, so it has access to health, no problem. I can say health is equal to 20. Because start, this method, is within the scope of character, right? You can even look at this very easily by seeing the curly braces here. It is within the curly braces of character. It's within the scope of character. So it has access to all the things defined within the scope of character. Again, if this was public, we can be outside of these curly braces. As long as we have access to character, we can get access to health. But in this case, it's private, so we have access to it within start. Now, this explicitly defined private void start for me, which I don't have to have that because in C# by default, if I do not define a public method or an access modifier defining how something is accessed, it will be default to private. So I can say this is public, I can say it is private, I can say there's another option for protected, which we'll get into whenever we start inheriting things. Because if I had this set as a protected integer of health, that means it can be used within here as well in this scope, but as well as objects that inherit from this class. So later on, whenever we create the enemy and the player, we can see how we can actually use protected fields, protected properties, protected methods outside of the class, but only because the class that we're using it in inherits that class. If we were to access it like we would access a public method or a public property or field, by just having the reference to character, it wouldn't work because it's outside of the scope and also outside of classes that inherit from it. So that'll make more sense later on. And notice this is a public class, right? So that's also defining its own access modifier within a scope of, well, we don't really have a scope defined here. If we think about where character is just kind of floating out there, right? There's a way we can handle this. If we look at maybe creating Let's say I get rid of this system.collections.generic using namespace thing up there. We'll get into that. And I come down here and I say I wanted to create a list. I want to type in list, and I'm going to create like I normally would. Oh, it doesn't even recognize what I'm trying to do. What I would have to do is I have to go through system, go through collections, generic, and then I have list, and it works. And like I said, I make a list of string, and it's equal to blah, blah, blah. So what I just did here is, if you don't know what this is, it's fine. We'll get to that in a second. But what I just did here was I actually included the scope, the objects that contain the method or the type or whatever it is that I'm looking for by going through the system namespace, which is like an object. You think of it like an object that encapsulates other objects. Same way character encapsulates health and start. So if I take this and I say, I go through system, then I go through collections, again, another namespace, then I go through the generic namespace, then I find list. So that's through the namespace. List is defined within the generic namespace of system.collections. But if I take that away, it's like, I don't know what this is. This is nothing to me. You've not defined a location for this. You've not defined where I can find this type of object. So I can't guess at it. I have no way of guessing. So what I can do is at the top here, we can say using system. Like it was before, using system.collections.generic. And that means that this document now understands that I'll be using this namespace for things. So if it looks for something, it knows to look inside of this namespace, it knows to look inside of this namespace, as well as the Unity Engine namespace. And the reason this is actually not darkened like this, how this is a darker text color, is because Unity Engine is currently being used in the document. If I get rid of mono behavior, it's not being used because mono behavior is a part of the Unity Engine Unity Engine namespace. So if I get rid of that and then I typed out mono behavior, it doesn't even understand what I'm talking about again. So it's like, oh, this is nothing to me. I don't know what this is. But then I'm like, oh, okay, what's in the Unity Engine namespace? And it's like, oh, okay, I understand now. I go through the Unity Engine namespace, I find the mono behavior type. There it is. That's the class I'm looking for. So instead of doing that, though, we just do the using Unity Engine namespace, just like that. And it understands. Pretty cool. So we'll get into all this later on when we use it. Just wanted to give you a quick introduction of how we're going to be doing this stuff. So the first thing we're going to be using for our characters and throughout this entire project is a property. A property is much like a variable, much like a field, in fact, that we'll be using. It's a member of an object. In this case, we have character as our object. And how we just created that, we'll create a private int called energy. And this is a member of character. This is a private variable that is of the type int, right? So this is a field. Now, I cannot decide what happens when I assign a value to this. I cannot decide what happens when I get a value from this. And what that means is, if this is set to private, I can access this within the scope of character. We just went over that, correct? And if it's public, I can access it outside of the scope of character. Pretty cool. But what if I wanted it to be read-only? What if I wanted it to be where I can actually set the value within character somewhere, however many times I want, however I want to do that, but then also read the value of energy outside of character? Make it where it's accessible outside of it, in a sense, read only. And there is an option for that if you want to keep it with a normal field called read only. But this allows you to define, similar to a constant, but you actually get to define the value once in your code at initialization, right? So you can't actually override that value later on and decide that it's something else. You set the value and it is that value. Whereas what I want to do is I want to be able to update energy maybe however I would like, whenever I'd like, inside of character, and then read the value somewhere else. So let's think about how we can do that. One thing I want to do is I want to keep private integer energy as a private field. And then I'm going to type prop, hit tab once, hit tab twice, and it's going to auto fill in this thing for me. And it says public integer my property, and then some gibberish out through there. So I'm going to take public integer, and I'm going to keep it that way. I'm going to hit tab once. It's going to go over to my property. And I'm going to call this energy with an uppercase E. is that you uppercase the first letter, and then you continue with your standard camel casing, where every word inside of that has an uppercase. Okay. So what this is going to do now is I'm actually going to get rid of this and fill it out as we go. So public integer energy. And now what I want to be able to do is decide what happens whenever I assign a value to energy, whenever I read a value from energy, whenever I set a value and get a value. Let's say whenever I set a value, I want to be able to calculate the value myself. So if I say energy is now equal to 5, I'll just, for some arbitrary reason, I'll take 2 points away from that. We can just see how that would work if I wanted to do something ridiculous like that. So I'm going to add my curly braces here, kind of like you would do for a method. And what I'm going to do is I'm going to type in, like I had before, get, curly braces, and then go down and do set, curly braces. Just like that. So you have get and set. Now this allows me to define what happens when I get the value from energy and whenever I set the value for energy. So if I come down here and I say, in my start method, for instance, if I say energy is equal to 20, that is calling the set method of energy, or the set value of energy. And then if I were to do energy, or we'll say that we log out energy, debug.log energy. Make sure we go through the property, the capital E. What that's going to do is actually going to use the getter on energy. So we can control what happens whenever we call the getter and whenever we call the setter. So let's say whenever I call the getter, what I'm going to do is actually return the value of the private field. So we have a backing storage field here, something that allows us to store the data. We're not storing the information or a reference to the information in the property. This is just a method for interacting with this private field, right? So we have get, return energy. All it's doing is taking the value from the private field of energy and returning it to whatever called the getter on energy. And we could do the same thing, so it'll be called right here. We could do the same thing whenever we set the value. So whenever I set the value by calling, or by setting the value to 20 here, what I am doing is I am passing it a value field that I can then assign to whatever I want, or I can do whatever I want to with it. So what it's actually doing is it's passing something called value straight to the setter. And I have the information of value, and this field actually contains the value that I passed to my setter here, so 20. So what I can do is I can say the private field of energy is equal to value. Again, lowercase means I'm talking about the private field and not the property, because we're storing the information in the private field, or at least a reference to the information in the private field. So energy is equal to value, value being 20. But what if I want to do something with that? And we totally can. I can say value, or not value, we'll say that energy is equal to value minus 2. Okay, so what's going to happen then is I'm passing 20 to energy. I'm saying, well, value is equal to 20 minus 2, so it's 18. So now energy equals 18. Now that's obviously pointless in this case, but I'm just showing you that you can do things with information if you need to, which is pretty cool. You can decide what happens whenever you set the value. Then whenever I return the value, I can say that energy is equal to 500 or whatever. I can do whatever I want to with the information before I return it. I could say it's equal to itself multiplied by 20. Okay, so maybe I want to do that. Maybe I want to call a method somewhere. I can actually call a method from this getter, return a value, and then use that information. Whatever you want to do. This is an example of how you can do that. But one thing I talked about was the read-only context, where I want to be able to set the value from within character. So what I can do is I can set the setter to be private, which means now I can only set the value within character. It is a private access setter, right? Can only access it within character. But the getter is default to public because the property is public. And that's how that works. So now we have something we can set the value in character, not elsewhere, and read the value anywhere. So I'm going to get rid of this. And what I want to show you now is what we'll be using throughout most of this. And the reason we're going to be using properties and not actually using the getter and the setter like we do here is because maybe we do want to use a getter and setter like we do here, but we just haven't come up with the need for it. And there's virtually no downside to using a property versus a standard field. So why wouldn't we do that and not just have to change the property to a field? But not just because it takes time to type it out and do all that stuff, but because later maybe we're using a third-party library that's looking for a field, and then we change it to a property. We have to recompile the entire third-party library ourselves to actually look for the property as opposed to the field, whereas the reverse, you don't have to worry about it. So that's a pretty good reason to do it. But we don't have to do it like this every single time. This is ridiculous if we don't have to use a custom getter and a custom setter. We're going to do something called auto-implementing these things. And the way this works is before I typed out prop, hit tab twice, creates it for me. I'm going to say energy again. And what this is going to do actually is it's called an auto-implementing property. And what it does is it actually creates this. The compiler handles creating this for us. The private int integer, the backing store field that we store the data in, store the reference in, is actually created for us in the compiler. So we don't have to worry about doing that. It does it for us. So all we have to do is call, like we did before, energy is equal to 20. And then we can also read it the same way. So that's pretty cool, right? So that does the same thing for us, but we don't have direct control over what happens with the getter and the setter, but it's so much easier to type out if we don't need that information. Now let's do this for the rest of our stats. We're using the same thing. Integer, my property, it's going to be attack. Prop, tab, int. We're going to have defense. And then prop, int. We're going to have gold. Attack and defense are going to be used to calculate whenever we're doing combat. Attack is going to be how much power the character does. Defense is how much damage the character can reduce from the power coming in. And then we're going to have a property that's going to be a vector2, and I want to call it room index. Now, what in the world is this? So a vector2 allows us to define an x and a y coordinate, and a room index, in my case, is just going to be the room that we're in, the x and y position in a 2D array that the room this character is in relates to. So think about it on like a grid, a chart, if we have, or a graph. If we have 10 by 10, our player's at 4 on the x and 7 on the y, right? So he's at 4, 7. We're going to be using that to determine where our characters are in the grid, in the dungeon. Pretty cool. And we define those pretty much like this. And we'll be using this later on. And then I want to set up a list of items. And in my case, my items are just going to be text. Just going to be string information, right? So we're going to have names of items that we add to a list of strings. Pretty simple. It's just to look at. It doesn't actually do anything, right? It's just something that we can collect as we go through the dungeon. So I'm going to create a property. And this is going to be like we did before. It's going to be a list. And I'll explain this as we go here. A list. And inside these angle brackets, we're going to type string. And then I'm going to have it called inventory. So if you're not familiar with what a generic collection is in C#, what we're doing is we're defining just like a normal type. We're saying list, right? Vector2, list, int, all the same thing. It's just normal types. And then inside these angle brackets, this allows us to define the actual type of object that it is. So list knows that it's looking for something, but it doesn't by default know what it's looking for. It can take any type of generic type. It could look for an int, it could look for a string, it could look for a vector2, it could look for any object type that you have, that you create, whatever it may be. So in this case, we have to tell it what to look for. So we're saying, you need to be looking for a type of string. It's going to be a string object. And that's all you need to know, because it needs to know what objects to allow. It's very type sensitive, right? It needs to know what type of object to allow and what type of object to return. So if we're actually looking for an item, we know that we're getting a string back. We're guaranteed to get a string back. And if we add an item and it actually goes into the list, we're guaranteed that that was a string. And that's what we need to know. So we're passing it the type of string, We could pass it an integer. We could pass it a vector too. Doesn't really matter. And pass it any generic type or any type. In our case, though, it's going to be string. And we're going to use this later on to actually add items to. The reason we're using a generic list as opposed to an array where you define a set length. So if you have 10 elements, when you initialize that array, you say, I have 10 elements. And later on, if you want to increase the number of elements in your array, you have to actually reinitialize the array, copy your information over, however you may want to do that. It's not a very clean way to go about it, but with a generic list, we can actually dynamically add elements to the list and just tack them on to the end, push them to the front, whatever it may be. Pretty cool, pretty simple to do. And we're using that because our inventory is going to be dynamic. We don't know how many items the player will have. We just know that they will be adding items to it. So it makes sense to use a dynamic generic list. And those are all the properties we need for our characters. We're going to have a couple of methods in here as well that we'll get to in the next lesson.